Campi Flegrei, or the Phlegrean Fields, is a volcanic caldera that stretches along the southern side of the Bay of Naples in southern Italy. In contrast to the surrounding Herculean volcanoes such as the well-known Mount Vesuvius, Campi Flegrei is a much larger and flatter volcanic depression, encompassing some 12 to 14 kilometers across, where most of the action occurs beneath the surface. During the past few decades, an uptick in volcanic activity has sparked concerns that Campi Flegrei might experience an explosive eruption in the near future. This video examines what Campi Flegrei is, why it might be poised to erupt, and what the consequences might be for Italy and the surrounding regions. Campi Flegrei literally means burning fields, because it is a large caldera created by the collapse of land after a volcanic eruption. Inside the caldera rim are 24 craters and volcanic edifices that extend west of Naples to the Gulf of Pozzuoli. The last large eruption, in 1538, built what is now called the Monte Nuovo Hill. Despite this dormant look, Campi Flegrei has been restless, with uplift of the ground, an increase in earthquake activity, and a continued emission of volcanic gases. Under Campi Flegrei, the ground is swelling. All around Pozzuoli, a town on the caldera, the land has been lifting by around 10 centimeters every year for a decade. That swelling is down to the movement of fluids, magma and volcanic gases, rising up to about 3 kilometers below the surface. Think of it like a balloon under the ground, slowly inflating and pushing up the ground above it. As the magmatic fluids accumulate in a vast labyrinth of magma chambers within the crust, they stretch and crack the rocks, causing what should seem like regular everyday tremors. In April 2024, for instance, there were more than 600 earthquakes of at least a magnitude of 2.5, the highest monthly tally ever recorded in a region. So scientists are concerned about the tensile strength of the caldera's crust. Studies show that its resistance to failure has decreased to about a third of the value measured in 1984. This means that even modest seismic activity could rupture the caldera, making way for an eruption. The trend of the recent earthquakes show a breaking rather than a bending of the rock too. This points towards a critical state of stress of the caldera. I made a documentary on Campi Flegrei back in 2019, and I discussed how the magma chamber has sealed itself underneath Pozzolana, the lithic debris expelled during the eruption of the third Phlegrean period. I have included a link to that video in the description. Pozzolana is known as Roman concrete. It is an extremely durable concrete, and the volcanic deposits, including the Pozzolana layers, affect the pressure and stability of the magma chamber. Right now, the Pozzolana is acting as a cap rock, and this Pozzolana is a truly strong material. It can withstand earthquakes and even problems due to deformation simply because of the nature of the concrete, and its ability to heal itself, so to speak. Studies show that Roman concrete can heal itself or self-heal small cracks due to the fact that unhydrated lime particles react continuously to water over time. So while that might seem like good news, at least for the people living there, it is a major hazard. This cap rock is increasing the amount of magma and volcanic gases inside the magma chamber because it is less able to depressurize, with it being somewhat imprisoned within this concrete tomb. Campi Flegrei and Mount Vesuvius are actually connected through the same magma chamber. So the depressurization that Campi Flegrei can't achieve through erupting is probably being achieved through Vesuvius. Yet the accumulation of pressure and magma within the parent magma chamber could mean that once it does explode, it could do so on a greater scale than even the most destructive past eruptions, which, let's face it, is bad news. An eruption at Campi Flegrei could be disastrous not only for Italy but for much of Europe and the world, since the caldera has hosted eruptions that have produced enormous volumes of volcanic material. The largest known eruption occurred 40,000 years ago, sending more than 500 cubic kilometers of material into the air. A similar eruption today would send a cloud of ash and volcanic gases, including volcanic poisons such as fluorine, which damages crops and leads to fluorosis in animals. It triggered a volcanic winter that devastated the surrounding European countries both near and far, and it had large-scale impacts on the world. If it happened today, volcanic ash would affect agriculture and long-term climatic effects caused by the injection of volcanic aerosols into the stratosphere. The immediate environments of Campi Flegrei are densely populated. Some 360,000 people live in that area, of whom nearly 200,000 people are located inside the caldera. A large eruption would involve a massive evacuation, which would be logistically complex. But if the eruption is sufficiently large, and some of the past eruptions were huge, there probably would not be time for that. Any caldera-forming eruption will involve very little time for people inside the caldera to escape. The land will be quickly suffocated and roasted by high volumes of pyroclastic flows. If the magmatic chamber itself collapses, there will be very little time for any significant evacuation. It will probably also trigger secondary hazards such as large tsunamis in the Gulf of Pozzuoli. Previous caldera forming eruptions occurred in the bay itself, and if that happened now, it could be dramatically tsunamigenic. All previous eruptions have generated enormous tsunamis, which invaded the bay because it is shallow. The height of these has been considerable and very dangerous. Campi Flegrei erupted the Campanian ignimbrite, and it was the largest volcanic eruption to have occurred in Europe in the past million years. The Campanian ignimbrite eruption occurred just before two key biocultural changes in the late Pleistocene, between the Middle Paleolithic and the Upper Paleolithic, and between the presence of Neanderthals and anatomically modern Homo sapiens. Disturbances in archaeological sequences are well documented throughout Mediterranean Europe at this time period, showing that this eruption had a large impact on the human populations of the time. The resulting eruption left traces in Greenland ice cores. It's thought that the ecological catastrophes that this eruption provoked led to the last Neanderthals being eradicated along with the first Upper Paleolithic Homo sapiens. The recolonization of Europe by modern humans from the east took place after this volcanic eruption and during the subsequent glaciation of 38,000 to 36,000 before present. The second Phlegraean period is dated at 35,000 to 10,500 years ago. It is marked by the deposition of the Neapolitan yellow tuff, the remains of a large underwater volcanic edifice now largely submerged with a diameter of about 15 kilometers. The last major eruption of this period occurred about 12,000 years ago, when a minor caldera formed in the central part of the main caldera, now centered at Pozzuoli. The third Phlegraean period, from 8,000 years ago to 500 years ago, when we noticed the white pozzolana that I had previously referred to, took place southwestwards first at Bacoli and Baiae, then shifted between Pozzuoli and Agnano. This more recent volcanic activity created the Lake of Avernus and Monte Nuovo, or in English, New Mountain. In several places, numerical age states using argon dating can be assigned to volcanic deposits in the region, particularly at 315,000, 205,000, 157,000 and 18,000 years ago, indicating the fact that volcanism has repeatedly occurred in this region. As a side note, if you're enjoying this video, please click the like button to help YouTube recommend it to others. Consider subscribing and clicking the bell icon to be notified of when we upload. We also have a Patreon if you'd like to support the channel, and you can find that both in the description and in a pinned comment down below. As of 2023, the underlying causes of seismicity and ground deformation at Campi Flegrei remain unknown. Two main models have been proposed to explain this phenomena. The first is known as the shallow magma model, and it discusses the movement of magma upwards and the possibility that it could eventually break through the surface and result in an explosive eruption. The alternative is known as the hot fluids model, and it attributes the activity to steam and hot gases generated deeper underground, which could end either by suddenly ceasing activity or initiating a phreatic eruption, which consists of the explosive release of hot liquids, gases and rock fragments, but is very unlikely to generate lava. While a phreatic eruption is less hazardous than a magmatic or phreatomagmatic eruption, it is still considered dangerous and could have far-reaching consequences. Better knowledge of which of these two models is correct would further improve the predictability of eruptions, with specific regard to identifying warning signs for Campi Flegrei and other volcanoes. However, given the location of the Campi Flegrei caldera, which overlies the Gulf of Pozzuoli, it's likely that if a new eruption occurs at Campi Flegrei, it would be an explosive volcanic eruption, and it's very unlikely that it would not have a phreatomagmatic element. Phreatomagmatic eruptions are by far the most dangerous form of volcanic eruptions, and it occurs when water and magma mix. A status report in February of 2020 stated that the Earth uplift around Pozzuoli was continuing at a steady pace, at an average of 0.7 centimeters per month since July of 2017, with no change in gas emissions or fumarole temperatures. By May 2024, uplift was at 2 centimeters per month. If uplift continues at this pace, eventually the ground will make way to produce an eruption. Having said that, the uplift is going to have to be quite substantial, because in the late 1970s and early 80s, the ground uplifted by about 3.5 meters and caused great concern, leading to the evacuation of parts of the town of Pozzuoli. The uplift was accompanied by increased seismicity but failed to culminate in an eruption. Then the ground subsided, which indicates that the magma chamber depressurized, probably via fumaroles. At Campi Flegrei, fumarolic activity is substantial. In particular, the Solfatara area, where the San Francesco fumarole have been monitored for decades, has provided a sample of gas emissions that have changed with time, both in terms of composition and volume. Gas output was very high during the 1980s uplift episode, and it is thought that the overall release of gases via the fumaroles and across hydrothermal vents helped to depressurize the system without triggering an eruption. Even more worrisome is that beginning with the 1950s, with the subsidence periods captured, the ground has risen in general by 2.5 to 3 meters. The ground has continued to inflate and deflate multiple times since that date, but in general the area has risen by this amount. The caldera floor is expected to exhaust its elasticity at an uplift of between 5 and 12.5 meters, since by then the ground is no longer capable of withstanding the load, and an eruption will follow. However, an earthquake or swarm of earthquakes could also perforate the Pozzuoli cap, which, despite its reputation as being quake-proof, is known to be susceptible to damage. On the 26th of April in 2020, a mild earthquake swarm struck the Campi Flegrei caldera, involving an estimated 34 events of magnitudes ranging from 0 to 3.1, focused around Pozzuoli. The largest quake in the sequence, a magnitude 3.1, was one of the strongest quakes since the last period of unrest in 1982 to 1984, yet no new fumaroles are reported. Volcanic activity escalated in January of 2022, and rose throughout the following year. In September of 2023, the seismic activity started rising again, culminating in a magnitude 4.2 earthquake on the 27th of September. This was the biggest quake in 40 years. Evacuation plans were drawn up in case as many as 360,000 residents should need to leave. On the 2nd of October, another considerable quake, this one measured a magnitude 4, failed to trigger contingency plans to move residents from their homes. Such events, while worrisome, were normal for this volcano, said most volcanologists, and were not taken as indicators of an imminent major eruption. Perhaps, as in the 1980s, the activity would simply cease. If an eruption was to occur, the best case scenario would be a repeat of the 1538 eruption, and that incidentally is as good as it gets as far as an eruption is concerned. Because while the eruption in 1538 generated a new mountain, essentially from scratch in a single eruption, it was tiny compared to the major caldera forming eruptions that could happen. In June of 2023, a study by Italy's National Institute of Geophysics and Volcanology and the University College of London declared that the volcano was close to a breaking point and was in a quote-unquote perilous state. The Italian Civil Protection Minister called on municipal authorities in Naples to speed up the drawing of evacuation plans and emphasised that evacuation would take place only in the case of absolute necessity. The mass evacuation plans would be tested in late May of 2024. Seismicity remained high. On the 20th of May in 2024, a seismic swarm of 150 earthquakes over the course of a few hours registered in the region, including a magnitude 4.4 quake that prompted fears in the neighbourhoods of Pozzuoli and caused some damage to buildings. The mayor ordered the evacuation of schools and of a prison. Because of the high risk, scientists and authorities are carefully watching the volcano at Campi Flegrei. The Vesuvius Observatory is at the front line of the field operations, using a mix of ground uplift measurements, seismic readings, and gas emissions to anticipate the eruptions. Volcanic eruptions are notoriously difficult to predict because of the complex nature of volcanic systems and their tendency to be unpredictable. Local authorities have devised contingency plans, including evacuation routes and public awareness campaigns, ensuring that populations are ready if the volcano explodes. Campi Flegrei is a sleeping giant that could wake up and have a major say in the fate of the nation and beyond. Nobody can truly say when a new eruption will occur or at what scale, but in the face of recent volcanic unrest and obvious continuing deformation of the ground, scientists and authorities must remain vigilant. Hopefully they'll be ready, given the stakes. Thanks for watching. Are you interested in animals? I've just started a second channel called Paleozoology that discusses extinct and extant animals with a current focus on the megafauna that once dominated and roamed Australia. I've released a video on the marsupial lion which existed in Australia during the time Indigenous Australians walked the continent. I've also covered the wombat that was the size of a car, known as the Diprotodon, or the largest terrestrial lizard known as the Megalania. I'd love to have you along for the journey as more videos are released. You can find a link to this channel and to the aforementioned videos in the description and in the pinned comment in the comment section. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.